Yo, what's really good, brothers and sisters? My name is O'Neil Barnaby, founder and director of the Black Math Academy, here with a video tutorial showing you guys what intelligent black society is all about. Today, I'm going to talk about a geometry question that you might see in a textbook or on a standardized test. So, like the rapper Black Rob would say, let's get it. So the question reads as follows. Find the value of x and y below. Give reasons for each step taken. So geometry is notorious for wanting you to explain the reasons for the steps that you do take. The reason being is because you can't make assertions about something without giving reasons as to why those assertions are true or not true. So you must explain yourself with every step that you do take. The first value that I'm going to get is the value of x. So in this diagram, we have a 2x up here, we have x degrees right here, we have 3x inside the triangle, and 2x inside the triangle as well. So the easiest one to get is x. So within this triangle, USV, we have 2x degrees inside, and we have 3x degrees inside. We don't have the value of the angle over here, so we have to obtain that one first. And the way we can get it is the use of the fact that these three lines, PR, YW, and TV, are all parallel to each other. So those three black arrows pointing in that direction signify that those three lines are parallel to each other. So what you want to look for in a diagram like this is any Z or any backward Z. It's a neat trick that you can use to find out missing angles within a situation like this. So if you notice, this line, that line, and this line form a backward Z. Now within that backward Z, you see these tiny, acute angles within the figure. And the rule states that when you have a situation like that, those two acute angles are actually equal to each other. The justification is called alternate interior angles. So this x degrees that's outside the triangle, that value of x is also within this angle over here. So this value here is x degrees. So now we have three angles within the triangle, the 2x, the 3x, and x degrees. So now we can find out the value of x here. So we know that any triangle, if you add up the angles, adds up to 180 degrees. So we can set this situation up where 2x plus 3x plus x is equal to 180. So 2x plus 3x plus x equals 180. Okay? So 2x plus 3x plus x is 6x. Okay? And then we can divide both sides by 6. And x is equal to 30. All right? So now we found the value of x. So that means within this triangle, this 2x value here, you plug in the value of x, which is 30 degrees, and you throw it in here, and you'll get the actual value of that angle. So 2 times 30 would be 60. 3 times 30 would be 90. And just 30 would be 30 degrees. So those are the values of the angles within that triangle. So we got the value of x. Now we have to get the value of y. So here's y right here. That one, I can think of two ways to go about getting it, but I'm going to deal with just one method for now. So if you notice, you have a point right here, and you have angles surrounding that point. Now, there's a theory in geometry that says that when you have angles surrounding a point, those angles add up to 360 degrees. It makes sense because you're going around in a circle, so 360 degrees are the values of the angles in a circle. I can prove it, but I'll probably save that sort of proof for another video. But with that being said, we know that this angle y plus this 3x plus this x plus this missing angle up here, it says s right now, when you add those values together, it is 360. So what we're going to do is fill in the values that we can and see if we can discover what we don't know, the value of y. So we know the 3x, that was 90 because x was equal to 30 degrees, and we just plugged it in there to find out what it is. So that's 90. This x degrees is 30. We know that. Now, this missing angle up here where the s is. So what I was saying earlier about you want to find z's within the diagram like this when you have parallel lines being cut by what's called transversals, these lines that hit it. You want to look for a z. So I can see another z. If you look at this line here, go down and go across that way, you have a z right there as well. Looks kind of slanted, but a z nonetheless. So the same rules apply. If you have any acute angles or obtuse angles within that figure, they're actually equal to each other. So we have a 2x here, which is acute. We have this missing value outside here, which is obtuse. So what we can do is that we know that the value of x is 30, so we can plug in 30 here, and 2 times 30 would be 60. Okay. And we know that this line here is a straight line, and every straight line in terms of its degrees is equal to 180 degrees. So that means this 60 plus this missing value is equal to 180 degrees. So the way to find it is to take 180 and subtract 60. That'll give us the missing value. So 180 minus 60 is 120 degrees. So this obtuse angle sitting here is 120 degrees. Now, following the rule with the z, that all the acute angles are the same and all the obtuse angles are also the same. So this obtuse angle is 120. If you follow the z, we have an obtuse angle here, which is our missing value. That has to be equal to 120 degrees as well. So this spot here is 120 degrees. So now within our angles surrounding a point, we have 90, 30, and 120. And the only thing missing is y. So we can set this up into another equation where 360 is the total, and what we're going to do is subtract the values that we know to find out what we don't know. So 360 minus 120 minus 90 minus 30. So we're just going to solve that. I'm going to add them up pretty quickly. So 120 plus 90 plus 30, that's 240 degrees. So in reality, what the problem says is 360 minus 240. Okay, so 360 minus 240 is 120. All right, so the value of x was 30 degrees, excuse me. And the value of y that we just found out is 120. So that's how you go about solving a geometry question like this. You have to find the value of x and y, and you must give reasons for each step that you take. And I was able to justify all of my steps that I took. So that's another example of Intelligent Black Society. Don't forget to like, share, and subscribe to our social media pages on Facebook, on Instagram, and on YouTube. And always remember that math is where it's at.